All right, so this video is going to be on how to find tangent lines and normal lines, because that's a really common problem that we look at when after we've known how to find the derivative, is we want to find, if we know that the derivative is the slope of the line tangent to a point, then we want to find that tangent line. We want to be able to write its equation often. So we're going to go ahead and do a couple examples here. So for our first example, the instructions are going to say that we want to find the points on the polynomial y equals x to the fourth minus 6x squared plus 4, where there is a horizontal tangent. All right, so if we think about what it means to have a horizontal tangent line, it means that you had like some sort of curve, and it could do anything, right? We could say that's our curve. A horizontal tangent happens when you're looking at the curve at the very top. So if you have a maximum, a horizontal tangent could also happen at a minimum. That's a perfectly horizontal tangent. And so if we consider horizontal tangents, then their slope should be 0, right? So that means that for us to do this problem, we're going to take the derivative, and we're going to see where that derivative equals 0. So if y equals x to the fourth minus 6x squared plus 4, then y prime, the derivative, would be 4x to the third minus 2 times 6 is 12, x to the first. And I don't even have to write that. And now I can go ahead and I can just set this equal to 0. So what I have is a cubic. I'm going to go ahead and factor that to solve it. So I have a GCF of 4, but also of x. And then that leaves me with x to the second minus 3. And I can go ahead and factor that further. I can use difference of squares, even though 3 is not a perfect square. So I'm going to say I'll have 2 sets of parentheses, one with a plus and one with a minus. And the square root of 3 is literally just square root 3. So I'm going to go ahead and write that. Okay, so right now I'm still doing that process where I'm solving for where the derivative equals 0, because the derivative represents the slope at the tangent, and the slope at a horizontal tangent would be 0. So at the location of x equals 0, x equals negative root 3, and x equals positive root 3, those are the 3 different points, those are the 3 different locations where we have a slope of 0 on that curve. And that's something that if you were to go ahead and graph the curve and plug in those x values and see where they're located on the curve, then those answers would make a lot of sense. So now what we need to do is we need to take those x values and plug them into the original equation just to see what our y coordinate is, because then we'll know what the whole point is. So I'm going to go ahead and say, not f, y of 0, so that's my function y equals, and I'm plugging in a 0. And you probably haven't really seen that notation before, but you are definitely allowed to write it like that. So you're just communicating to whoever's looking at your paper that you took the y equals equation and you're plugging 0 in for x. All right, so when we plug in 0, we end up getting 4. And then we can go ahead and plug in negative square root 3. So we have negative square root 3 to the fourth minus 6 times negative square root 3 squared. And then plus 4 on the end. So if I think about this, the negative square root 3 squared, I'm going to go ahead and change my color here. Negative square root 3 squared is just going to be positive 3, because that'd be negative root 3. I'm going to go ahead and write this kind of small. Negative root 3 times negative root 3 is positive square root of 9, and that's just 3. So now we'll go ahead and say that that part right there is negative 6 times 3. That's going to be negative 18. We still have that plus 4 on the end. Okay, and then we have negative root 3 times negative root 3 is root 9, and we're going to do that again. So root 9 times root 9 is root 81. Root 81 is just 9. Okay, so we have 9 minus 18 minus 4. So that's 13 minus 18, that's negative 5. Okay, so this equals negative 5. And then we're going to go ahead and do it again with the positive square root 3. So y of positive square root 3 is positive square root 3 to the 4th minus 6 times positive square root 3 squared plus 4. And you'll notice in this case, hopefully, that the negative square root 3 and the positive square root 3 are going to give you the same result because you're doing them to the 4th power and the 2nd power, and so it just made those numbers positive anyway. So that's also going to equal negative 5. So we have 3 points on the graph where there is a horizontal tangent. We have the point 0, 4. We have the point negative root 3, negative 5. And then we have the point positive root 3, negative 5. And if you were to graph and check all of those, you would find that that was true. Okay, so we have another example. This example says find an equation of the tangent line to y equals 1 plus x squared over square root x when x equals 1. Okay, so if we are finding the tangent line at a specific value, then we're still finding a tangent line. That still means that we need the derivative because we need the slope at that point. So I'm going to go ahead and look at my original function, and I'm going to rewrite it because it looks like a quotient rule right now, but it doesn't have to. So I'm going to split that fraction apart. I can do that if I have a plus on the top. On the bottom it's different, but on the top you can split it. So I've got 1 over the square root of x plus x squared over the square root of x. So I split that into 2 fractions. And now I'm going to rewrite this as x to the negative 1/2. And then the second part I'm going to think of as x squared over x to the positive 1/2, right? Since I'm leaving that square root on the bottom, it's still a positive exponent. And I can go ahead and simplify that a little bit. X to the 2 and x to the 1/2, when they're written as a division problem like that, it means that what I really have is to take away 1/2, which is 1.5. We'll go ahead and write that as 3/2. So what I did, I haven't actually done the derivative yet. I've just simplified the problem to make the derivative easier to find. Okay, so now I can go ahead and actually find my derivative. So I'm going to say, here I'll use the other notation. I'm going to say dy dx, so the derivative of y, is I take the negative 1/2 and move that to the front. So negative 1/2 x, negative 1/2 minus 1 is negative 3/2, plus multiply the 3/2 to the front, 3/2 x, and then 3/2 minus 1 is positive 1/2. Okay, so I'm going to go ahead and simplify that the way that it looks a little bit because it's going to make it easier for me to plug a number into it if I actually know kind of how I'm doing that. So for the first piece, I'm going to say negative 1 on the top. And then on the bottom I have 2, and that x to the negative 3/2, that belongs on the bottom because it was a negative exponent. So 3/2 means that I'm square rooting x to the third. So I'm changing that back into the radical form, one, because it's a good skill to have, and then two, because most of you guys are not going to recognize how to handle your numbers when they're in that rational exponent. It's a little bit easier to think of it as a radical. All right, plus, and then I have a fraction for the next one too. I've got 3 over 2, and then x to the 1/2 is really just the square root of x. Okay. So that's what I have right now. I'm going to go ahead and evaluate that for 1. So dy dx evaluated when x equals 1 is -1 over 2 times the square root of 1 to the third plus 3 times the square root of 1 over 2. So if we simplify that, 2 times the square root of 1 to the third is really just 2. So what we have here is we have -1/2 plus, I don't know if you could hear that, but my stomach just growled really loud, plus 3 times the square root of 1 is just 3, so 3 over 2. And so that means that the slope of our tangent line is -1/2 plus 3/2, which is 2/2. And so the slope of our tangent line is just 1. So awful lot of work, but we do have the slope now. So I'm going to save that. And for us to write a tangent line, we have to have a point and a slope so that we can do that point-slope form. So what I'm going to do is I'm going to go back up here, and there's my original equation right there. So I'm going to take that original equation, I'm going to write it over here. I'll do this in a different color. I have y equals 1 plus x squared over the square root of x. And I need to know what point I can plug in to my tangent line. So I'm going to say y of 1, because I want to know what the y coordinate is when the x coordinate is 1. So y of 1 is 1 plus 1 squared over the square root of 1. And that's 1 plus 1 is 2 over the square root of 1 is 1. So what that tells us, text, is that we have the point with an x coordinate of 1 and a y coordinate of 2. So at this point now, I can take those two pieces of information. Oh, can I put a box around that? Yep. I can take that 1, 2, and that slope of 1, and I can go ahead and write my tangent line. So my tangent line is y minus the y coordinate, which was 2, equals the slope times x minus the x coordinate, which was 1, and there's the equation of my tangent line. All right, so we're going to add one more thing to our notes before we do the next example. So here we're going to go ahead and put the definition of what a normal line is. So a normal line is the line that is perpendicular to the tangent line at the given point. Okay, so we're going to go ahead and do one last example. Find the equation of the tangent line and the normal line to y equals x squared plus 1/2 x plus 5 at x equals 0. Okay, So to find the equation of the tangent line and the normal line, we're going to need to have a point and we're going to need to have a slope. So first, I need the slope of the tangent line. So I'm going to say y prime, so I need to find the derivative. So that's going to be 2x plus 1/2. Okay, there's my derivative. Now I need to evaluate that derivative at the location so we can find the slope at that specific point in the graph. And so y prime of 0 is 2 times 0 plus 1/2. And so that means, and I'm going to label this a little differently this time, I'm going to say that this is the slope of the tangent line. The slope of the tangent line is 1/2. Okay. We also need to have the slope of the normal line. And so to get the normal line, we need something that's perpendicular to that slope that I just had. So the slope of the normal line is going to be the negative reciprocal of 1/2. So I'm going to flip it and then change the sign. So -2/1, or we can just call that -2. All right, so there's our two slopes. That means that what we have to do next is we have to go ahead and find the actual point that we're going through. So I'm going to take my original equation and I'm going to plug 0 into it to see what the actual y-coordinate was of that point. I know the x-coordinate is 0, but I want to know the y-coordinate. So I've got 0 squared plus 1/2 times 0 plus 5. So that means that the point that I'm using to write this line is the point 0, 5. All right, so now I can go ahead and write my two lines. I have the tangent line is y minus 5 equals the slope times x minus 0. And then the normal line is going to be y minus 5 times that slope times x minus 0. All right, and that's it. That's all you had to do.